wonderful learning individuals. It is a pleasure. I thank you so much for pressing the play button. How are you all doing today? I am Johnny, your host with HomeCountry Mathematics. It is so great to have you. Please feel free to stay and to also grow. Let us learn some maths, shall we? All right, exciting. Oh, yes. Okay, we are continuing on with Chapter 1-2, Order of Operations, because PEMDAS is fun. Let's do this. Okay, we are continuing on with some more practice problems to, improve our skill sets and mastery of algebra, or evaluating algebraic expressions. Let's do this. All right, the question is, first let's write our knowns. Let's do that first. Okay, knowns. What is given? What is known? All right, we have A equals 7. B equals 3. And C equals 5. Okay. Here is the question. They're trying to challenge us, but this is easy for you guys. You can do this. We all believe in you. Okay, let me rewrite that. A squared subtract and parenthesis b cubed. Again, don't let this all worry you guys and gals. They're just letters and numbers. Let's have fun with it. Okay. And close bracket. That's it. A squared subtract b cubed minus 4ac. So let's have a quick look at this. First, I will share this. Order of mathematical operations, parentheses or brackets. Occasionally you'll have square brackets. We don't have any square roots or anything we're working with right now, so don't worry about that. We are working with x squared, so that is something we have to make sure we complete. Any division, multiplication that may be in the problem, we will do. And then lastly, addition, subtraction. Again, the more problems you do, the better you're going to get, and you'll also know when to do what. Okay? Well, the first thing we got to do is substitute. Anytime you see the letter A, you substitute 7. Where you see the letter or variable B, we substitute 3. And C, variable C, we substitute 5. It is that easy. Okay, here we have a squared. Let's do our substitution. I like and prefer to use brackets with any exponents. A is 7, close bracket, and squared. I like it because it creates clarity. Now here I could actually use my own square brackets. There's nothing that says I can't. The reason I'm doing this is because I have b cubed and I want to use parentheses again. Square brackets is replacing these. Let's continue. B is 3 and cubed. Make sure you don't forget any exponents or anything. Let me fix that a little bit. Okay, subtract 4. And I can also use brackets. Anytime you see a variable next to a whole number, think multiplication, because that's what it is. And C is 5. Close with that and finish with a square bracket. There we go. Isn't that nice and clean? All right, we have a scenario which is kind of a left-hand side, right-hand side, or neighbor 1, neighborhood 1, and neighborhood 2. Right here, I like to put an imaginary fence line. So we have a left-hand side. So this is the neighbor on the left, and all of this is the neighbor on the right. So we can solve these independently of each other because if you look, our last step is step 3, which is addition subtraction. So anytime you see a plus or a minus separating in this similar fashion, that's what we have happening. Okay? Okay, so left-hand side, I can actually do this. Quickly. I highly recommend you study your multiplication and or times table if you have not yet. We all support you, those that are all watching, cheer you on. Yeah, so it's recommended because it'll help you solve any mathematical problems quickly, effectively, efficiently, especially looking for common numbers between whole numbers, or common multiples between whole numbers, common numbers with fractions, and so on. Good luck in your studies. Let's continue. 7 squared is the same as saying 7 times 7, which is 49. Okay? Don't forget your subtraction sign. I'm going to continue using the square brackets just for now. 3 cubed. What does that mean? That means 3 times 3 times 3. It's whatever value is inside. That's what you're seeing here. Being multiplied by itself 3 times. 1, 2, 3. Okay? I could do these in pairs. 3 times 3 is 9. We have one more 3 to do. 9 times 3 is 27. There's our answer. Okay, so I'm going to write 27. I don't need any more brackets. Subtract. This is easy. Quick 4 times 5 is 20. And I'm going to finish with my close bracket. All right, there you have it. Okay, the left-hand side neighbor is done. Okay, we don't need to do anything more. We're kind of waiting. This side's waiting. We have to finish this. Okay, whatever's inside the brackets. Okay, must be completed. This is quick math. 20 take away, bear with me. 27 take away 20 is 7. Okay. And I'll clean that up. And then I'm I'm just going to put my 49 down here. And then I'm going to go subtract. That's this one here. And 7. 49, take away 7. We'll do the quick subtraction because why not? 9 is greater than 7. Perfect. We can straight subtract. That is 2. There's nothing to do here other than just bring the 4 down. Done. Oops. And our answer is 42. All right, let's do a quick check. Yes, let's go. Turn that up. That is the answer. Perfect. Good job. Again, guys and gals, if you're watching and you want to practice before myself showing the work to you, by all means, wait till I write the problem out, such as this point. At this point is when you want to pause. Okay? Bear with me while I try to write with the mouse. Not so easy. And then you can attempt to solve it yourself. Now, by all means, please don't get frustrated if you get an incorrect answer or make an incorrect step. Sometimes we make silly mistakes, and that is okay. The main thing is to learn from that mistake. Again, the more you grind, the more algebraic expressions that you evaluate, the better you're going to get. You're going to know all the different steps and the little nuances you need to do first. Okay, it's great to have you. Let's continue on. And good job. Okay, here's another one. We have X and Y. Perfect. Is it possible to write knowns? All right, perfect. That's what I want. Knowns. X equals 3. And Y equals 4. All right, let's substitute. Here's the problem. X. Again, I don't really look at it as a problem. I look at it as a fun challenge. Because this is fun. X, Y cubed plus 8. Alright, at this point, you can pause if you like. Attempt to do it yourself. Good luck. Oh! There's one more little piece. Hold on before you pause. Hopefully you didn't pause before I said this. Again, if you do it this way, that's fine. It's good practice. We have a divide 12 here. If you've been following along, you'll know that I'm not a fan of this. I call this linear. It being written in this fashion creates discourse between those that are, I know sometimes you'll see it on the internet, be like, can you solve this? Right? And then people will get the right answer, and there will be a group of people that get the wrong answer. And it's mainly because, well, one, brackets, they don't put in the brackets, and a division symbol, which creates kind of arguments, if you will, between people. So I don't like doing this, but I do love seeing the fact that they have brackets here. Now let me point something out here quickly. I should explain all this before you actually attempt a problem. Let me show you something. This is a left-hand side, technically speaking, right? In a sense it is. Well, actually, it's not, because we have a division. What does division mean? Division means numerator over denominator. So we have not a left-hand side, we have a numerator, okay? And this is our denominator right here, okay? Anytime you see a division symbol, think fraction. I always put my problem into fraction form. I always do. Now, what I want to explain here is this side here, the numerator part. All of this stuff inside the brackets, because this is multiplication, all of this inside the parentheses belongs to the x. The x has ownership of this. Okay? This, all of this belongs to the x. Okay? So if you choose to move this anywhere, you have to move it wherever you move x. They belong together, okay? They're connected at the hip because of multiplication, right? You cannot change that. So that's what I wanted to kind of express and be explicit about. So this division doesn't mean, oh, well, 8 is divided by 12. No, that's incorrect, okay? The parentheses stops that. That's kind of like, hey, no. I'm inside this. You cannot even do anything with me because I'm inside here, if that makes sense. All right, let's just work the problem. So just take note, okay, guys and gals, take note. All of this belongs to the x, okay? All right, so myself, I prefer to write this in a fraction form. So what I'm going to do is go like this, and I'm going to erase this. Bye-bye. Writing it also in fraction form creates kind of organization in your mind. You can clearly see what belongs where. So the numerator part belongs to itself, and the denominator part belongs to itself. They're separate or independent of each other because of this fractional line. Okay? Let's substitute. X. Wherever you have an x, place a 3. So I'm going to go 3. We have a bracket. I could, again, because I like doing this because I have a cubed here, I want or would like to use rounded brackets or parentheses. So we have y. Wherever you see a y, place a 4. And cubed. Don't forget your exponent. Plus 8. Okay, and then finish with a closed bracket. Fractional form. It's clear there's not much to do in the denominator because it's just a singular whole number. Okay? Let's continue. We have 3. I'm going to continue with the square brackets. We have 4 cubed. 4 cubed equals 4 times 4. I'm going to work it here. Don't worry, I'm going to erase it. 4 times 4 times 4 times 4. Okay? We have 4 times 4, which is 16. Multiplied by another 4. 6 times 4 is 24. Carry the 2. 4 times 1, 4. Plus 2, 64. Alright. 4 cubed is 64. Plus 8. That is all divided by 12. A few steps to go still. Okay, I'm just going to carry it over here. Hopefully we don't run out of room. We have 3. At this point I could go with rounded brackets. You can change them. I'm going to do my addition right here quickly. 64 plus 8. I'm avoiding using calculator. 8 plus 4, 12. Carry the 1, 7, 72. Okay, we have 72. Close bracket. Don't forget, whoops. Don't forget your denominator. Apologize, I'm kind of squeezing this all in. Now we have 72 times 3. You know, to simplify things, it's smart or wise to actually reduce right now. How many times does, I'm kind of running out of room here. I wish I could do the long division. How many times does 12 go into 72? Let's try 5. Let's try it, okay? 5 and that's 10. Carry the 1, that's 6. So that's 16. Not enough. 12 times 6. 12. Carry the 1. 6 plus 1 is 7. There we go. 12 times 6 is 72. So I could actually factor 12 out of that. So I'm going to go 12 times 6 equals 72. Just so I remind myself. Good enough. I'm going to factor 12. Let me show you the work. 6 times 12 is 72. So I'm taking 72 and breaking it into two numbers. And 12 times 1 is 12, correct? So now I'm at the point where, well, we all know that 12 divided by 12 equals 1, correct? Any value multiplied by 1 is going to be the same value. I'm going to cancel the 12. Therefore, we're left with 3 times 6 all over 1. And 6 times 3 is 18. Do apologize, I'm running out of room. There's our answer, 18. Okay, hopefully I didn't make any mistakes on the way. I would love to check. To be honest, I would love to check, but we're running out of time. I appreciate you watching. Hopefully you learned a lot. It's great to have you. I am Johnny. I'll see you in the next video. Take care for now, and good luck in your studies. Thank you for watching.